Okay, so I'll go and give the IP address here. No shutdown, and IP address is 192. Sorry, IP address is 192.168.100.1 255.255.255.0. Okay, let me go and check my connectivity with the PC. I'll say ping to 192.168.100.2, right? Okay, do you want to see the ARP? What happens in ARP? Okay, fine. What I will do is I will capture the packets on this particular link. Okay, so Wireshark is a software which captures the packets which are coming to and from the link. What I will do here is, I don't want to see all this information. I will just filter some of the informations, and now I'll say that I want to see only the ARP information. So I'm preparing a filter, and I will tell him don't show this thing stuff. Okay, just give me some time. As I was telling you, have I done anything in the PC or router? Nothing. They are just talking to each other. Every minute hundreds of packets are coming. So these packets are not coming now. It is coming behind, but he is not displaying. So I have created a filter. Okay, I have created display filter. I'm saying don't show me all these things, I'll get confused. I want to see some basic stuff. Okay, fine. Now let it be here. I will look at it later on. I'll go back to this router. I'll give a command, show ARP. It is quite normal. He knows his own IP address. He knows on which interface that IP address is. He also knows on that particular interface I have a MAC address, whatever it is. And so he has done a mapping. He has done his own mapping, layer 3 to layer 2 mapping. It's quite normal, and you can see this. There is no magic here. Clear? Now I will use another command which you people need not use now. Okay, you need not know about that command. That is called as debug command. What we do with the debug command is, we normally try to see, in a production network, debug commands should be used only as a last resort. See, when you say ping, or when you say when you say ping to this particular address, you see, okay, ping reply has come, you are happy. But behind that, to send that particular ping, so many different processes are involved behind the scenes. router has to do so many other things. So all these things will be shown to you if you give a specific debug command, and that's a very processor intensive command. If you run a debug command, it will take lots of CPU, processor memory. Okay, utilization will be very high. So in a production network, debug commands, first of all, a junior level network engineer will not have the access to give that command. Okay, even if there is access, it should be the last resort for troubleshooting. When you have failed to troubleshoot using show commands, and you have tried everything else, you are not able to analyze what is the fault, where is the fault, at last you can give the debug command. Okay, you should use it very carefully. Now what I want to see here is, I will say debug I want to see what is happening behind the scenes when the ARP is happening. Okay, and also I would like to ping. So I want to see, I will also do a behind the scene of ICMP packet. Ping is a ICMP class of, ping is falls in ICMP. So I'll say debug, sorry. I don't want to say anything else. Fine. Now I will just ping. This is the first ping packet I am sending to the PC. Ping 192.168.100.2. Right? Okay, I think it is over. I'll just stop all the debugs and we'll just analyze what has happened. Okay. It is telling sending 100 byte ICMP equals to 192.168.100.2. Okay, timeout is in 2 seconds. That means if I don't receive a reply within 2 seconds, it is a failure. First of all, what has happened? IP ARP creating incomplete entry for IP address 192.168.100.2. He has understood that I have to send the packet on fast ethernet 0/0 because this is 192.168.100.2, and from the routing table he has understood that it is on fast ethernet 0/0. Fine. But there is no entry of MAC address. There is no entry because he wanted to look. Now first is he decided that I have to send the packet on this side. What is the next step? He has to build the packet. To build the packet he needs destination MAC address. For that he had referred to the MAC address table. In the MAC address table he has found for source IP address there is a source MAC address that is there. For destination IP address there is no MAC address. That's why he is telling incomplete entry for the particular IP address. Are you getting my point? Okay. Then what is the next line? IP ARP sent. A ARP request has been sent with a source address of 192.168.100.1 and the source MAC address is whatever it is. Okay, and he has sent it to a destination of 192.168.100.2, and since he doesn't know what is the destination MAC address, it is kept blank, you can say. Okay, and this ARP request was sent on out of fast ethernet 0/0. Are you getting my point? Any doubt here? Fine. He received a ARP reply. He received a ARP reply from the source 192.168.100.2 Okay, this is the source. That means the PC has replied, and this must be the MAC address of that particular source IP address, and it has been sent to destination, that means 100.1, that means to him. Okay, and this packet was received on fast Ethernet 0/0. Then he had sent the packet, and he actually got this one reply, but during that process the first packet got lost. Okay, so there was a success rate of 80%, 4 by 5, because when he was sending it, maybe that side had to resolve it, but that side didn't have to resolve it, but first packet got lost usually. But here it is the ICMP. When he was sending the ICMP echo packets, he is receiving a echo reply. Echo reply received. Who sent it? 100.2 has sent it. To whom? The destination address is 100.1. Isn't it interesting? How many times echo reply you have received? 1, 2, 3, 4. Okay? Is this clear? Now, this is the debug command from my router. We are yet to see the captured packets. Yes, I do have some ARP, right? This is an ARP request. Now I have clicked here. When I click here, you will get the detailed information in the down field. Here, what it is telling, it's an address resolution protocol ARP, and it's an ARP request. If you go detail into this, he will say protocol type is IP, means inside that it's a header, it's a, look here, it will tell you hardware size, protocol size, opcode. Opcode is called as operation code. Operation code, request is 1, reply will be, I think it will be 2. But who has sent it? Sender MAC address is that router's MAC address. Okay, sender's IP address is this. Inside the address resolution protocol, it is this information is there. Target MAC address, don't know, and target IP address is 100.2. If you look at the Ethernet header, most interesting thing, the source MAC address is router's MAC address. Destination MAC address is broadcast MAC address. It has been sent to everybody. All apps MAC address. Didn't I tell you ARP request will be a broadcast? Isn't it a broadcast? If you want to go a little bit more detailed here, you can click here. You can. This is the Ethernet header basically. Okay. I just stop here. You can see the destination MAC address is this. Okay, it's a broadcast MAC address. It is basically telling. And source MAC address is this one. And most interesting thing, can you see the source MAC address? Only the last 64 bits are properly visible. And no. Here it is. Everything is visible. I think 3, 4, 5, 6, 7, 8, 9, 10. Yes, everything is visible. It's the MAC address, total MAC address. Okay. Then here, what type of packet is next? That is the ARP packet. Okay, next ARP packet. And if you want to see the reply, they would have told you that the reply is in it's a request packet. They should have shown me the reply. Where is it? But most probably this is the reply. This is a reply packet. This reply packet, if I expand this subtree, it is telling no, this is not the we are not getting here. Okay, let me check this. Let us check this ICMP packet. This is the ICMP packet. This ICMP packet, in the Ethernet header, you have the source MAC address. This is the destination MAC address. Since I am using a VMware PC, so the MAC address is showing as VMware, this one. Okay, and this is the layer 3 IP header. If I expand this subtree, you will see that it is IP version 4. Header length, normally IP version 4 will be 20 bytes. It can be 20 to actually 60 bytes. Source IP address is 100.1, destination IP address is 100.2, and in the IP header, it is going to tell you, this IP header is going to tell you next what type of header is coming. Next, in the TCP layer 4, what type of header is coming. Here it is telling next the protocol is ICMP, and ICMP will have a protocol number 1. Okay, next protocol is ICMP. And this is the ICMP protocol. If you expand this, it will tell you it is ICMP, it is type 8, it's a echo request packet. It is a echo request packet, and it is telling that response is in frame number 95. If you want to get the reply of it, you just click here. Packet 95 isn't displayed. Okay, 95. Okay, replies are getting blocked here. It is only showing the packets which are going from the routers to the I might have blocked something by mistake. So it is only showing the packets which are going from the router to the PC, not PC to the router. That's why you are not able to see the reply. That's why I was not getting the ARP reply also displayed here. Okay, you can see all our ping request here. Can you see this? All our request packets only. And this is, see here also you can understand who has 192.168.100.2. Tail to 192.168.100.1. This was the ARP packet. Are you getting some idea now? Okay. Now, stop this capture for once. I'll prepare this router for telnet. Now, you from this PC, if I say IP config, you can say his IP address is 192.168.100.2, right? And if I ping 192.168.100.1, I am able to get the reply. But if I say telnet, it is telling me password required but not set. Password required but not set. Why it is telling me like that? If I go to the router directly, and if I give the show run, tell me one thing. Underline console 0, if you have, yesterday you have given login. Underline console 0, if you give login, what happens? Whenever you give login word underline console 0, you are basically telling the router that you need to ask for a password whenever somebody is entering through line console 0. Correct? Correct. Did I anytime go and give this login word underline VTY? No. And remember, I was telling you, whenever somebody is telnetting to the device, they are trying to enter the device through line VTY. And under line VTY, there is a word called login, which I have not done. It is from the factory configuration. But under line VTY 0/4, there is a word login. That means anybody who tries to enter through the line VTY, that means anybody who tries to remotely connect to the device, the router should ask for a password. Are you getting my point? But since there, and you tell me one thing, what happened yesterday when you removed the username and password, but the underline console 0 login local was there? It was asking for username and password, but it didn't know how to verify, as a result of which you were not able to come in. You had to restart the entire router. Correct or not? So that's the same thing which is happening. Router knows he needs to ask for a password. He doesn't know how to verify. So he thinks, as a security procedure, I will not let anybody in. Okay? There are a couple of options. The first option you should never apply in a production network, but just to show you I am doing this. What I will do, I will remove that login word itself. Okay, I'll go to the configuration mode and I'll go under line VTY 0 / 4 and I'll say no login. I'll say no login. That means remove that particular word, which you should not do under production network. Okay, because otherwise everybody will be able to log in from any remote corner of the network. That's a security hazard, right? So now I'll go to this PC. I'm in this PC and I will try the command again. The router has allowed me. Correct or not? That's why you are able to see that R1. Right? Right. But we should not do that. Instead, I will put the login word back and I will put a password. Password, let's say Cisco. Okay, now let me try. I'll just, exit out of it. Okay, I'll try again. Have you understood this? It is same as your line console, right? Now you are thinking, no, only password will not work. I need to have a username and password. Actually, if you have a username and password, it is good, because under show users, you will be able to know who all are logging in at that particular moment. Okay, so I go to the router again through console. Okay, again I'll go to the router again through console. I'll exit out. I'll go to the configuration mode. I'll give him a username and password. Username, let's say Cisco. Password, Cisco 123. And if you already have a username and password configured and you are using for the line console 0, you can use the same username and password to enter through line VTY. Okay, and what I have to do next, I have to go to line VTY 0 / 4 and I will say login local. Same thing, whatever I was doing for line console, I am doing it for line VTY. Okay, now let me go and try. Username, sorry, it was wrong. What was the password? Cisco 123 or only Cisco? Cisco 123. Okay. This is just to come into the, through the line VTY. But now, if I put enable, it is telling me there is no enable password set. I will not let you in, and you cannot bypass this. Somehow you could manipulate the user level in line VTY and you could come in initially, but you cannot cross this stage. For that you need to have a enable password or enable secret. Okay, that which I have to give through Wireshark. Sorry, through this one. So I'll say enable password, let's say India. Okay, now again I will try this command enable. It is asking me the password. Okay, I'll say India. Is this part clear? Now I would like to show you why telnet is dangerous. Okay, I'll just log out. I'll go to my PC. I'm opening the command prompt and I'll say telnet 192.168.100.1, right? Asking me username and password. I could enter. Telnet is successful, right? Look here. This is the conversation which was going on between my PC and the router, which has been captured by, it's asking username. Of course it has come two times, okay? So CISCO was the username, password was Cisco123, and I have typed enable and the password is India. So anybody who is hearing on that particular link, they will simply capture, and next time, if I'm a hacker, I have got the username and password of your router. Is this clear? That's why you should not use telnet. Okay, what you should use is SSH. I will show you how to do SSH now. Fine. Of course, I'll be working from my telnet window only now. Okay, because I'm in the PC, I can work from here. Okay, I'll go to the configuration mode. Remember, I'm working remotely. Okay, if you want to see, you can see this. You can put the command show users. It is telling that there are two active users. One is through line console 0 and one is through line VTY. Yes, presently line VTY1 is active, and line VTY, who is the user? It's the Cisco. Normally username will be your name. Is this clear? Okay, now I'll configure this for SSH. Okay, for that, step number 1 is you need to have a host name apart from router. That means all the Cisco routers are coming as router and all Cisco switches are coming as switch, right? So you need to change the host name first. Routers should not have any host name called router, and switches should not have any host name called switch. So you give some other name. That is step number 1, which has already been done here. Step number 2 is to create a domain name. Step number 2 is to create a domain name. How do you do that? You go to the configuration mode. You say IP domain -name. Normally it will be like your company's name. Let's say cisco.com. Step number 2 is clear. You create a domain name. The command is IP domain -name. I've given cisco.com, and it has to be done in the global configuration mode. Step number 3 is to start the RSA algorithm, because encryption is involved, right? Now the Cisco routers will use RSA algorithm to encrypt, okay, to make the public key. So I will say crypto key generate RSA. Crypto key generate RSA. I will give enter. Now it is asking me how many bits do you want to use to generate the keys. Okay, if you use more more number of bits, then what will happen? It will be more strong. Okay, but there is a disadvantage, because every data has to be get encrypted, right? So if you use more number of bits, what is going to happen? It will be more processor intensive. In a production network, the router will become slow if you use more number of bits. You can use from 360 to 4096. By default it is 512, but if you use 512, it will not be very strong. If you use like 4096, it will become very slow. You have to select something in the middle which is strong as well as not very processor intensive. Most of the people tend to follow 1024. It will take couple of seconds. Now it is taking 3 seconds, right? If I would have done something like 4096 bits, it might have taken, let's say, some 7 seconds. Okay, you could have seen the difference actually. But this is clear. Only one thing is left. Under line VTY, that means under my virtual port, by default Cisco router allows only telnet. By default Cisco router allows only telnet protocol. Now since you want to do SSH, you need to enable SSH protocol under line VTY. Okay, so you need to go to line VTY. Okay, I'm under line VTY and I'll give a command transport input, and if I put a question mark here, it will show me all the protocols which can be allowed. If you say all, it will be all. Okay, but here I want to specially allow SSH, right? But now if I give transport input SSH, what will happen is the SSH will get enabled, telnet will get disabled. Now if you want to allow telnet as well as SSH, you need to put a space and you can say telnet. Are you getting my point? But in your packet tracers, it will not allow that space and to write one more command. So there you just try transport input SSH, that's all. Fine? Enter. Once it is done, my job here is over. But you need to understand one thing, that in order to do telnet, in order to do SSH, you need to first of all do all those steps, perform all the steps which are required for telnet. So it is better that once you telnet and see whether you are able to do it or not. That means you have performed all those steps. Now specially whatever is required for SSH, you can do that. Are you getting my point? If you are directly trying to enable SSH, you need to perform all these things like username and passwords, underline VTY 0 space 4, login local. You need to have an enable mode password or enable secret password. Then SSH specific commands. Clear? Okay. I'll just exit out. I'm out. I'm out of the, PC. Now, in order to do SSH, this is again one more application through which you can access the serial cable as well as you can do telnet and other things. Okay, this is one more protocol. This is called as TerraTerm. This is free, just like hyperterminal. So if you want to go through serial, you can click on serial and you can say enter. But now I don't want to go through serial. What I want to do? I want to do SSH. Click on SSH. Can you see the port number 22? Yes. Where 192.168.100.1. Login as password is okay. before doing anything else, I want to show you this also. In that, can you see, before doing telnet or any other things, first of all there was a three-way handshake. Can you see synchronization, acknowledgement packet, and then acknowledgement? Before the actual data goes, you will have this TCP three-way handshake. Now, these are the SSH packets. Okay, these are the SSH packets. If we see this, it is written as encrypted. Okay, now if I click here, if you see here, under the SSH protocol, you cannot see anything except that it is telling SSH version 1 and the payload is encrypted here. Actual data is getting encrypted, you are not able to see anything. You can see the source, from what source to what destination it is going. Destination port number is 22, okay, but you cannot see what is the data. If I say follow TCP stream, this is what you get. But when in telnet I said follow TCP stream, you are able to see clearly what was going on, right? Entire conversation. Here we are not able to see this. That's why SSH is a secure protocol. Of course, guys, it takes some time to explain these things, but at the end it is interesting. And if you my intention is that I want you to make I want to make the things interesting for you people. Okay, it's not that one command, I'm telling put show run and you are looking at show run. Yes sir, I have got it. When I'm saying put show run, I'm actually wanting you to analyze the running configuration inside and see. Right? Today, while you are doing the lab, you might have understood. Those who have done the lab, those who have practiced in their home, they are able to do it. I am not naming anybody. Those who have practiced properly, they are able to do it properly. And those who have not practiced, you are facing trouble. I'm not saying come with doubts. In order to have doubts also, you need to have some practice, right? That's what I was telling. Okay? Have you understood? Okay. Try that SSH and this one. What's the time? Okay, we do have time. Try the telnet and SSH. It won't take much time.